Hey, what's up? And welcome again to these videos with like different techniques and tutorials, I guess, and electronics. So today I'll do mesh analysis, and I'll show you how to do it. We'll start with a simple circuit that has three resistors and two voltage sources. Now, mesh analysis, we need to determine the meshes, and a mesh it's kind of like a complete loop inside a circuit. For example, this one here, it's a mesh because it's a complete loop from the positive. It goes like that, and so that will be one mesh, and then this one will be the second mesh. It goes in this direction. And by determining the values of the meshes, we can determine the current inside the circuit, and therefore we can determine everything else we need to do. So, how do we start with this one? Well, first we mark in the resistances, so this would be R1, this would be R2, and this would be R3. Doesn't make a difference really, but I just like to do it. Now, the next step we do is choosing a loop. Now, we can choose actually like to go in this direction, like that, and very importantly, we choose the same direction for the second one as well. So the current flow will be in this direction. We assume it's in this direction. Now, we can't do it differently. We can put one in one direction and then the other one in the other direction. Both of them will need to be either clockwise or anti-clockwise. Now, unlike node analysis, mesh analysis is based more on the currents, so we don't need to use any nodes to determine the voltage inside the circuit. Now, first, let's try to put some signs. So this one here, it goes through the negative to the positive, so to have a minus sign of, no, first let's name them. This one will be A and this one will be B. So mesh A. Now we follow this loop, so the current will go to the negative, to the goes to the negative end, and it comes out the positive, so that will be minus 10 volts, and it will go to this, so we'll make it positive and make this a negative, so it will be plus 5 ohms. Well, it's not only 5, it's also the current, which is IA. So we'll name this one IA and we'll name this one IB. Okay, now why is it 5IA? Well, the current goes to the resistor and we'll use the voltages to determine the current. So as we know, V is equal with IR. The current will be I and the resistance will be R, which is 5. Now, this is simple enough because there was no other current than I. Now the problem will be here for IB. Well, we keep going with this loop first. So we'll have a positive and a negative in this direction. And then we look at IB, and the direction of IB, this one it's positive, and this one it's a negative. This one positive and this one negative. Then again positive and negative. But let's focus on this one to finish the first loop in mesh A. So now we do plus, and then we do the two currents. Current A is coming from the top, current B is coming from the bottom. So they conflict from each other, so it will be IA minus IB. Then we close this one, and times the resistance, which is 20. So that would be times 20. Okay, and all of it will be equal to 0 because of Kirchhoff's current and voltage law. Now, what we do is minus 10V plus, we simplified, 5IA plus 20IA minus 20IB equals 0. And this will be like minus 10V plus 25IA minus 20IB, which we can also write it as 25 20IA minus 20IB is equal with 10. Okay, this sounds simple enough. Now let's go to mesh B. Let's see. So for mesh B we already notated them. So let's start with the voltage source because that'll be easier. Because it goes in this direction, then the voltage will be a positive, so it'll be plus 20 volts because the current flow goes from the positive to the negative. And the same for this one. Now we do it the reverse. We write plus 20 and this time we do IB minus IA. We like flip them around. We close this one plus, and then again this side's left alone, so it'll be only A, then IB. Alright, equals 0. You know, this method here, it's more effective the more meshes you add, because this is a 2 mesh. It's really simple, but you can use this method for like 3 meshes or 4 meshes or 5 meshes or 6 meshes, or no matter how many meshes, you know. It doesn't always have to have voltage source inside of them. As I will show you in the next example, you can do it even though they don't have a voltage source, you know. And then let's keep going. So then it will be 20 volts plus 30 IB minus 20 IA. Therefore 30 IB minus 20 IA is equal with minus 20 here. Oh, okay, now let's rewrite them. So we can do like 20 IA minus 20 IB equal 10, and here is like minus 20 IA plus 30 IB is equal minus 20. Okay, let's see what we can do here. We can do simultaneous equations to determine IA and IB, and I think the easiest one will be like to eliminate IB, so we multiply everything by 3 in this side and we multiply everything by 2 on this side. So we'll get 5075 IA minus 60 IB equal with 30, and then on this side we get minus 40 IA plus 60 IB, which is equal to minus 40. Okay, let's add them together. So here on this one we get 35 IA. Okay, let's focus there again. Then B just cancels each other, so they disappear, and then it will be equal with plus this one, it will be minus 10. Therefore IA, the current IA, is equal with, let me get my calculator. Actually I don't need the calculator, do I? Because it'd be like minus 3.5 amps. Yeah. Okay, so this is the negative current apparently, and that's alright, I guess. Now let's determine IB, which should be easy. So it'll be minus 20 times minus 3.5 plus 30 equal with minus 20, and then minus 20 times minus 3.5, so 20 times 3.5, then it's equal with 70. So this one is 70 plus 30 IB equal with minus 20. Therefore 30 IB is equal with minus 90, and therefore IB is equal with minus 30. No, minus 3, I'm sorry. This is interesting. So the values we get aren't so bad, but they are negative values. Maybe it's because I used the clockwise. Maybe if I used anti-clockwise, then the values would be different. Anyway, so yeah, these are the two currents inside the circuit, which is IA and IB. and then we can determine the value of this current here if we add them together. So that one will be minus 3.5 plus minus 3, and that will be minus 6.5 amps. Yeah, and if I applied Kirchhoff's law, which will, like, let's say IA, and then this one will be IB, and this one will be I total, we will get we'll get the right answer anyway, because those two currents come in positive and this one goes up negative, so it will be plus bracket minus 3a plus bracket minus 3.5a, and then it will be minus bracket minus 6.5a, which will be equal to 0. So it is working on this one here. So basically we determined everything. We determined the currents, and we can determine like the voltage drop inside each resistor as well now by just using the currents. So this one was pretty simple because it was a short circuit as well. It's not a big circuit. So I'll see you on the next example with a bigger circuit then. Okay, so here will be the second circuit that we do in this video, and as you can already see, this one is a bit more complicated because it's got no voltage sources here in the top loop on the top mesh. I don't know if it's using now 3 meshes, and there are 3 current sources. Now let's see, first thing we do as usual is to mark in the direction. There you go, make sure all of them have the same direction. Okay, and you name them. So this will be current A, this will be current B, and this will be current C. Now let's see here, we start with mesh. No, actually let's start by plotting the positive and negatives. So this is current A, so on this side this will be positive, this will be negative, this will be positive, this will be negative on this side, and on this side this will be positive, this will be negative. Now for C, this one will be positive and negative, positive and negative, positive and negative. Now for B, so this one will be positive, negative, this will be positive, negative, and then this one will be positive and negative. Okay, now let's get to it. So that's our mesh A. So mesh A. Okay, so it's the flow goes from the negative to positive, so that will make it a minus 100. Then it will go from the positive to the negative, so that will make it plus 60 IA, and I get a no because the voltage is equal with the resistance times the current. Now this one is a bit more complicated, so this one will be positive again, so that will be plus 60 bracket, that will be IA, because it's for, we calculate for this mesh, minus IB, and then plus again, and again we have the same kind of principle. It will be 100 seconds, the page it's, there you go, it will be 100 bracket again, IA minus IC this time. Okay, and all of it will be equal to 0, so let's calculate. This would be minus 100 plus, that would be 60, that would be 120, that would be 220, 220 IA minus 60 IB minus 100 IC. Okay, and then we get 220 IA minus 60 IB minus 100 IC, which will be equal to 100. Good. So this one is for the first one. Let's go to the next one. So there will be like mesh B, and then this one will be 60. We'll start from this point here. Bracket IB minus IA. Then we go here to the next one, which is plus 40 IB, and then plus 80 IB minus IC. Sorry, man, this I had to sketch my nose. There you go. So that'll be 100, 180. So it'll be 180 IB, and then this will be minus 60 IA, and then this will be minus 80 IC. Okay, so this one was a bit simpler because there is no voltage, and that's how you do it when there is no voltage. You simply just don't include it in, and then all of it will be equal to 0. Then, and now let's go for the last one, which will be IC. So mesh C, that will be, we start from the voltage, so that will be with the minus, so it will be minus 50. Oh no, I realized that I made a mistake here. Basically I forgot to include the 20. Okay, that's very simple to resolve. Because it goes to the positive and negative, it will be a plus 20 equals 0. So then this one won't be equal to 100, it will be equal to 80, because we move the 20 on this side as a minus 20, and then minus 100 plus minus 20, that will give us 80 volts. Sorry about that. Okay, let's see, so that'll be minus 50, then it will be minus 20, because the loop goes in this direction. Then it will be plus 100, and now it will be IC minus IA, and then we'll go, sorry, my nose is itching, and then we'll go in this direction, so it will be again plus 80, and this will be IC minus IB, and then it will be plus 20 IC, and all of it will be equal to 0. So then it will be, let's see, IC it will be 200, so it will be 200 IC, then it will be minus 100 IA, and that will be minus 80 IB, equal with, those two together will give us minus 70, and minus 70 on the other side will be a positive 70. Now let's rewrite everything here. So that will be 220 IA minus 60 IB minus 100 IC equal to 80. This one will be minus 60 IA plus 180 IB minus 80 IC. And now this one will be minus 100 IA. That one will be, what's the value of B? There we go, minus 80 IB plus 200 IC. This one will be equal to 0, and this one will be equal to 70. Okay. Now what I recommend you to do is to do the matrix analysis, matrix method. And the matrix method basically is, if you just wait a second, so I can have it here for me to see. There you go. It will be the reverse A1, the A to the power of -1, the reverse matrix A, which is this one here, the I values, and the B, which is the answer. Is it really this one? I got just a second. Yeah, and this one is derived from the formula Ix is equal with B. Okay, so I guess I'll make another video about matrices because they are useful for this kind of circuit. Because I mean, yes, you can do simultaneous equations, but that one will take a lot longer than doing it the matrix method, which will basically do one of those square brackets here, and we're going to write the values. So yeah, just paste them here. So it'll be 202 minus 60 minus 100, and then the next values, which is minus 60, 180 minus 80. This answer will be 0 minus 6 and 100. No, and what am I writing? Sorry, that'll be 100, that'll be 80, and that will be 200. Sorry about that. I don't know where I got those numbers. I think it's because I have like an example of a matrix calculation on my screen, so I followed that on by mistake. Sorry about that. Anyway, there to do the bracket, because to be honest, I'm not like really the best at matrices, IA, because I said, like, usually I do it with simultaneous equations, but I should really do it using matrices, because that way it's a lot simpler. So it'd be IA, IB, IC, and then on this side it'll be equal with the answers, which is 80, 0, and 70. And we need to determine the negative matrix here. Just a second. Okay, I'm back. So I did the calculation like off camera, because if I do it now I'll have to explain how I did it, and that will take ages. I didn't do the calculation in the best. I just like there's like the online software, like online programs, online websites that calculate it for you, and I just used one of them to calculate it for me, because like saves a lot of time. It's a lot easier than me like finding those values. Anyway, now our next step is to find the current, basically, which is this one here, by multiplying the invert with the results there. So is it? Oh, it is plus 70. Sorry, I almost did a mistake again. I almost put like minus 70, and that would have ruined it. Okay, let's start with like IA equal with. So how do we do it? Well, we multiply this from up to down with this one from left to right. So the first one we'll do is 80 times 0.004, and then we just add them plus, and then it's 0.000, that's 0 anyway, 0.5 times 0, that's 0 anyway, and then plus, and that's like 0.002, yep, times 70, and then the answer from this one will be A, so that will be 80 times 0.004, so that will be 0.03, 0.32 plus, and now we like replace this one with a 2, and then we replace this one with a 7. That will give us 14, so 0.14. So the current then will be equal with 0.46 amps. Okay, so IA it's 0.46 amps, and we just repeat those for the other ones. So let's say IB, it's equal with 0.003 times 80 plus 0, because like 0 that's whatever, 0 plus 70 times 0.005, which is equal. So let's go by the calculator. Let this one replace with a 5. That will give us 0.35. Then replace this one again with a t, and then replace this one with an 8. That will give us plus 0.24, and that will be equal with 0.59, yeah, 59 amps. Alright, and now let's go to IC. So IC it's equal with 0.003 times 80 and plus 0. Oh my god, sorry, it was actually 2. It was a 5, it was 0.002, because it's 002 in this one. So that means it's like 70 times 0.002, 14, so that would be 0.14. So this one would be 0.36 amps. There you go. Okay, good thing I noticed that mistake. And then the last one was like 70 times 0.005. And this one was done, that was equal with 0.24 plus 0.35, which was supposed to be 0.59 amps. Okay, so we have those three values. So IA it's equal with 0.46 amps, IB it's equal with 0.36 amps, and then IC it's equal with 0.49 amps. Alright, so I guess we'll check our results. So let's see, in this one, no, let's take a simpler one. Let's take this point here. No, actually this one I think it'd be easier. Okay, so because I don't know, it's not from a book or from anywhere. It's like I just put up some random values to see if yeah, there's different values, like random values. Anyway, let's see. So this one IA would be 0.46, and it will go inside here, and then that will be IC, that will go inside in this direction, which is like actually I'm not actually sure how to check this one. I mean, I guess I will have to like take these points, maybe like this point here. Anyway, but I'm pretty sure it's correct. I'll like pause it and like see if I can find a way to like check if it's correct or not. Hello, I'm back. So I think I found a way to determine if these answers are the correct answers, and here it's the way I checked. So to this resistor the current is 0.46 because the current A, and to this resistor it's 0.36 because that's the current through IB, and in this resistor it's 0.59 amps because that's the current through IC. Good. So let's take, for example, these two nodes then to calculate it. Okay, so we also need to determine the current inside this resistor and inside this resistor. So let's start with this resistor first. We'll simply do like we wrote in the formulas here, A minus IB, because A is the hard value from B. That'll be 0.46 minus 0.36, and that will give us 0.1. Okay, so this one will be 0.1 amps going through it. And now you can see where this is going, because this one it's in the reverse direction, it will be a minus. So okay, sorry about the message about then. So you can see where this is going. So like the analysis. So in this node, current IA is coming in, so it's positive, so it'll be IA, and then it will be minus IB, because that's the case going the reverse way, and then again positive IA, so no, not positive, plus the current here at the output, which will be 0.1. Therefore IA is 0.46 minus 0.36 plus 0.1, and all of it will be equal with, oh no, sorry, it's minus here, because that's the output. So currents that coming out from this node are negative. Anyway, yeah, and that will give us 0. So this proves that the current IA and IB are correct, at least, because it fulfills these two resistors. So the currents are good in this section. So that means if this node here with the currents, it will prove that IC it's correct as well, and we reinforce that IB it's the right answer as well. So I did again. So we got this one and this one, and we do again IC minus IB, because IC is the bigger value from these two. So it'll be IC minus IB, and that will be IC will be 0.59 minus 0.36, and that one will be equal with 0.23, this point here. Okay, and then we are going to do, so IC it's going in the reverse, so it will be minus IC plus IB, and then plus the current, which is 0.23. So as you can see, it will be 0.59 amps plus IB, which will be 0.36 plus 0.23, and then that will be equal with 0. This is the minus here. So this side here it's correct as well. To be honest, this circuit's a bit more complicated because of the 3 voltage sources and the 3 meshes, and I think the next one will be something similar to this one but simpler. Anyway, and as you can see, like, this way of calculating takes less time than neutral analysis as well, because you'll just need to determine the values of each mesh, make it short with the currents, and then you apply matrices to it, which, to be honest, like, the calculation of the matrix will take longer, but we can do simultaneous equations as well. If there are only 2 of them, that would be simpler. If you try to do simultaneous equations with 3 of them, then yeah, that will take a bit longer. Anyway, so yeah, so these are the answers here. IA is equal to 0.46, IB is equal to 0.36, and IC is equal to 0.459. At least I think they are the right answers, to be honest. I should look at, like, in books to see if I can take some examples from them and use their values to, like, make sure they have the correct answer. But to be honest, like, if you do it this way, if you make your own random numbers, it will add into the challenge of trying to figure out if this is the right method and if this is the correct result. I mean, I believe this is the correct answer, to be honest. It doesn't seem too big for these values because these are quite big resistors, so it should be somewhere around along these lines. Anyway, I'll see you to the next circuit then for the next example. Oh, and yeah, this will be the third circuit we're going to solve. So I thought about making, like, a bit simpler, making only 2 loops, so we don't need to use the matrices, and we can, like, check the answers to see if they are right. But I also thought, like, what if, we just kind of make it a triangle, like make it an unusual shape. I mean, like, I guess you'll never see a circle like this in a triangle shape, but I guess you'll see some of them in like a different shapes, and it's important to know how to calculate it. So we'll apply our steps. First off, we choose a direction, which will be like usual, this direction here, and then we're just going to like add them. So we'll make this one IA, and this one IB. This will be positive, this will be negative, this will be positive, this will be negative, this will be positive, this will be negative, and this will be positive, this will be negative. There you go. Let's start doing it. So let's see, mesh A, that will be, so let's start from here, from the voltage source. So it comes from the positive, so that will be a plus 12 volts, and then it goes to the 4 ohms, so that will be plus 4 IA. Then it goes to the 8, so there will be another plus 8 volts. Then it goes down to here for the 8 bracket IA minus IB. Alright, now let's calculate it. So that will be 20 volts. Let's see here, plus 12 IA minus 8 IB, which will equal to 0, and that will be 12 IA minus 8 IB. That will be equal with minus 20 right here. Now let's do for mesh B. I mean, this is the thing, it's already easy than nodal analysis. If I try to use nodal analysis on this one, it will take me a lot longer to do it. So, I mean, like, yes, nodal analysis, it's a bit easier to check if it's right, and it's it helps a lot more with like complex circuits. But mesh analysis, it's really simple when you have circuits that have only like resistors and voltage sources or current sources. Anyway, let's keep going. So then let's start from here. So that will be a minus, no, I don't know, it will be positive as well. That will be plus 6 volts, then plus 8 IB minus IA, and then we'll go up, and that's a negative, so it'll be a minus this time, so it'll be minus 8 volts, and then another one which will be plus 12 IB. So let's make this one shorter, so it'll be minus 2 volts plus 20 IB minus 8 IA. Okay, and we like simplified this one as minus 8 IA plus 20 IB equal with 2. So yeah, now we can use it. We can simply use simultaneous equations because it's faster than using matrices. I say like use matrices only when they're like more than 3 or more loops, because it makes it a bit faster. Even though simultaneous equations are like a lot easier to do, because for example here, no, it's super easy. I can just multiply this one by let's see, I can just multiply this one by 2, and then I'll multiply this one by, so this one will be 24, and then 24, that will be 3, yeah, times 3. Okay, and then from this two we'll get 24 IA minus 16 IB equal with minus 40, and then on this one I get minus 24 IA plus 60 IB, which will be equal to 6, and then we'll just add them together. So the IA's cancel, that will leave us with, that will be a 5 4 44 by a second. Okay, it says that they can't even have a minute of peace. Okay, let's see where we left off. So that'll be 44 IB, and that will be equal with 6 plus minus 40, that'll be minus 34, and that one, therefore IB will be equal with, let's do quickly, 34 divided by 44, 0.772. So that would be minus 0.77. Yeah, it'd be simple this way. Now let's go for the next one, which will be IA. So 12 IA is equal with, let's not put equal yet. 12 IA minus 8 times minus 0.77, which will be equal with minus 20. Therefore 12 IA, it is equal with, see here, so 8 times 0.77, that will be 6.16. IA is equal with minus 20 minus 6.16, and therefore IA is equal with, let's see, 20 minus the answer, that will be 13.84. I'm about to sneeze. Divide by 12. So IA is equal with that answer divided by 12, and that will be equal with 1.153. So it will be equal with 1.15 amps. Let me show it's the right answer actually. So let's see, that will be a plus, and then that will be a minus, and then the plus, oh no, it's the wrong answer, I'm sorry, it's minus 20, and then IA, sorry, the page is trying again, it's equal with minus 26.16, which is equal with, let's see, minus 26.16 divided by 12, minus 2.18, yeah, minus 2.18. Okay, and in conclusion, IA is equal with minus 2.18, and IB is equal with minus 0.77. Why do I keep getting negative values though? Like, yeah, I chose the values randomly, but I don't know. Maybe it's because, like, maybe if I turned it around the other way around, did that way instead, to give me both positive values. Anyway, so this was the third question. Again, another simple one. I mean, I guess I'll do one more because it's under 50 minutes. I mean, like, I don't mind doing one more example to have, and I think the next example will have currents in it. Anyway, but to be honest, like, mesh analysis is quite easy, especially if there are only two loops. It's easier than nodal analysis. And then when you get the current, you can simply just multiply the current by the resistor, and then you get the voltage. You can, like, quickly find out the voltages inside all of them. So yeah, this was the third example in this video. So I'll get ready the fourth one, and I'll see you in a bit then. Okay, so here will be the last circuit example for the mesh theory, which will have a current source in it. I don't think what other type of, like, problems I can make, to be honest. And I didn't want to do it with only two loops because that would be too easy. You'll see why in a second. So I decided to make it 3 loops to, like, make it a bit more challenging and a bit harder. So let's see. Let's start with the first loop here. Let's start with the annotations, like the marking the direction, then marking the signs. So this would be plus, this would be minus, this would be plus, this would be minus, this would be plus, this would be minus, plus, minus, plus, minus, plus, minus, plus, minus, and this goes in this direction, which will be interesting. You'll see in a second. So that'll be IA, this will be IB, and this will be IC. The advantage of using of having a current source inside the circuit is that you already know what IC is. So we look at the system in this direction, and you may think like IC is 5 amps, but no, actually IC is equal to minus 5 amps because it's going in the opposite direction. The direction is pointing out. So if there was only 2 loops and you know already one of the values in one loop, you just need to calculate for the other loop and that's it. That'll be the end of it. But now because we know the mesh for this one and we have 2 more, it still adds up a little bit, like we still need to work a bit more. So let's see here. So let's start with mesh A. And then there you go. And then this one will be, it will go in from the negatives, so that'll be minus 50. This one will be plus 20. So by that I thought I was hearing something. That was like plus 20 IA, and then plus 16 bracket again IA minus IB. Those 2 values here. All right, let's see. And all of it will be equal to 0. So let's quickly calculate it. That will be 36 IA, and then that will be minus 16 IB equal with 50. That was simple enough. And then let's go for mesh B, and then we can calculate this. So that will be plus 16 bracket IB minus IA, close the bracket, and then we go up by 1, so there'll be plus 10 IB, and then the next one plus 4 IB minus IC. Now let's calculate equal 0. So let's do this one. So that'll be 16, that'll be 26, that'll be 30. So that'll be 30 IB minus 16 IA minus 4 IC. Okay, and all of it will be equal to 0. However, we already know the value of IC because IC is minus 5 amps. So we can do that here, which will give us 30 IB minus 16 IA, and that would be minus 4 times minus 5, that would be 20, so that give us 20 here equals 0. And then we got minus 16 IA plus 30 IB equal with minus 20. And there you go. So now we have these 2 equations. So we have 36 IA minus 16 IB equal 50, and minus 16 IA plus 30 IB is equal to minus 20. Let's see, what can we multiply this one by actually? I guess then that's it. I actually don't know. Okay, I guess we'll have to do it the way that I don't like to do it. So I guess we'll multiply this one by 30 and this one by 16 to make those 2 match, but that will give us like a ridiculously high value, so that's why I don't like to do it that way. This is so 30 times 36 times 30. Okay, which this one will give us a value of 1080. My god. IA. Okay, there's no point in calculating IB either because it will be deleted anyway, and this will be equal with, I think it's like 1500, isn't it? 50 times 30. Yeah, 1500. Now let's go for the one under. So 16 times minus 16, they give us minus 256 IA, and this one will be equal with 20 times 16, 300, so it will be minus 320. Okay, now we add those two together, so then we get 1808 minus 256, which will give us 824. Okay, IA, and then this one will be equal with 1500 minus 320. That will give me 1180. Okay, now is the big calculation, so let's see what number we get for this one. So IA is equal with 1180 divided by 824, and it will be equal with it's not that bad, it's 1.43 amps. And to be fair, that sounds right. Okay, so we found IA, now we just need to find IB. Okay, now let's look for IB. So let's say let's take this one, why not? So that'll be minus 16 times 1.43 plus 30 IB equal with minus 20. So let's say 16 times 1.43, that'll give us 22.88. So it would be minus 22.88, okay, plus 30 IB equal minus 20. So 30 IB is equal with 2.88, and then IB is equal with, let's see, 2.88 divided by 30. Hopefully it's not a really small number. It will be 0.096 amps. There you go. So we have IB as well. So now we should have like all three of them, because we know that IA is equal with 1.43, IB, which is in the middle, is in between those two, it's equal with 0.096 amps. Okay, and that's the problem really, because we got the three currents, and then by having the three currents we can easily calculate the resistances between them. And I think it's easier if you have a current source than a voltage source when doing this type of circuits, when you use this method, because by simply having the current source here, you just eliminated the entire loop here, as you saw like in these examples here, because otherwise you have to do mesh A, mesh B, and mesh C. So basically it made it from a 3-mesh circuit by adding the current source, it made it into a 2-mesh circuit. Okay, hopefully you found this one useful, and it's shorter than the node analysis, to be honest, because there isn't much to this. I mean, it is much, but it's just a simpler version. It's easier to calculate, and it's also the very first thing that you learn in university and school, really, how to calculate. So yeah, hopefully like it helped by using kind of like different type of circuits, you know, like using 3 voltage sources, or like making a triangle shape, or like adding 2 loops. I would do it for loop as well, but that'll take a long time. It takes too long to just calculate the value for the matrix, really. So yeah, probably next week I'll probably do either superposition theorem, or I'll do Thevenin theorem. And yeah, and maybe next week I'll upload both of them actually, because superposition is really easy to do. It's literally like even shorter than doing mesh analysis. It's even simpler than that. And it's very useful as well. Anyway, so this was the video for this week. I'll see you next week then. Bye.